All right, thank you everyone for joining this webinar by the Australian Passive House Association covering the topic of world-leading passive house commercial buildings with case studies. My name is Chris Nunn. I'm the Head of Sustainability at AMP Capital Real Estate, and I'm also the current chairperson of the Australian Passive House Association. Starting with the name, the word passive house, don't be fooled. In German, house means building. It's not just a house. So a rat house is a council building. A Krankenhaus is a hospital building. So house can really mean building. So passive house doesn't mean passive residential home. It can also apply to all building typologies. There are hospitals, schools, offices, all bearing the name passive house. So it's not purely a residential standard, which I think is an important myth for us to dispel in the Australian context. I really like this cartoon because it demonstrates for me the evolution in design thinking of passive house. Historically, on the left in the 19th century, we used to build buildings that were simple, but they were uncomfortable and energy intensive. Then we figured out how to make buildings comfortable, but they were complicated and energy intensive. And that's arguably where we are now. The image on the right represents a future state for most buildings, but it's the current state for passive house. These buildings are comfortable and energy efficient, as well as being much simpler. The building fabric does most of the work of keeping the building comfortable, so you don't need a lot of expensive energy intensive heating or air conditioning, and they don't leak, so you don't need a lot of fan power to ventilate the building with fresh air. There are 5 key principles of passive house: continuous insulation, airtight construction, minimizing thermal bridges, and high performance glazing with a mechanical ventilation with heat recovery system to provide fresh air. I won't dwell on the technical component of passive house. That's probably a subject for another day, but I do want to touch on the benefits of passive house. First and foremost, passive house buildings are healthy. There's a constant fresh air supply with no recirculation, which means there's no VOC buildup, no buildup of particulates or CO2, carbon dioxide. And the attention to air tightness and thermal bridging means there's no drafts, there's no condensation, there's no mold, and there's less risk of airborne allergens because there's a filter on the mechanical ventilation with heat recovery system. So passive house buildings are better for people's respiratory health. Passive house buildings are also comfortable. They deliver stable temperatures year round. They don't overheat and they don't get cold. And you might say, overheating, not really a problem. I'll just turn the air conditioning on in Australia, or cold is not an issue in Australia. But actually more people die annually from the cold in Australia than they do in Sweden. And this is a result of the way we build our buildings in Australia. No one's going to die from cold in a passive house because they're well insulated, they're well sealed, and they stay warm in winter. And that's an issue even in Australian climates, as we see from that statistic about the number of deaths from cold. You know, winters in Australia, while they're mild by global standards, if indoor environmental quality is poor and comfort conditions are allowed to drop down to 10 or 15 degrees Celsius, well, that's enough to really cause people health problems and mean that they're desperately uncomfortable. The other great feature about passive houses is they're energy efficient. Passive house buildings are dramatically more efficient than conventional buildings. Passive houses use up to 90% less energy to cool and heat than conventional buildings. They're also high quality. Passive house buildings are well sealed, so they don't leak conditioned air, and the insulation and high performance glazing mean they've got great acoustic properties, so they're good for shutting out external noise like traffic, aeroplanes, or train noise. Passive house buildings are also resilient. A passive house building will function in a heat wave. They're resilient to the predicted impacts of climate change. We know that climate change means we'll have hotter summer temperatures and more heat waves. Passive house buildings are much more resilient to these conditions and will continue to perform while other buildings overheat. And so they will stay habitable much longer in the event of a heat wave. While a commercial passive house building in a blackout might last as long as its diesel generator can run the essential services, pretty soon it's going to get too hot because blackouts typically happen concurrently with heat waves in Australia. So When we've got a blackout, it's usually hot. So the passive house building might continue to be habitable and operate, and there's a business continuity benefit there. A non-passive house building might quickly overheat, and everyone in the building might have to go home from work. So passive house buildings are more resilient to the predicted impacts of climate change. And passive house works for all building types. The subject of this webinar is passive house for commercial buildings. And I want to emphasize that the passive house planning package is an adaptable software tool that can facilitate the design and construction of passive houses for all building types. There are passive house high-rise office buildings. There are fire stations, schools, hospitals, apartment towers, aged care facilities, social housing, and tens of thousands of individual dwellings around the world. And it works everywhere. It works in all climates. The Passive House Planning Package software tool that underpins the Passive House standard is sensitive to the climate zone of every project. It prompts the designer to adjust the amount of insulation, the type and extent of glazing, and the amount of shading required depending on the local climate, meaning that a passive house building will be well suited to the climate in which it's built. There are passive house buildings in tropical, humid, cooling-led environments in the world. So that's suitable for instance, a Brisbane or a Darwin. You could apply passive house even in those really humid, cooling-led climates. And passive house has a long history. It's got a 26-year track record. It's been running since 1991 when the first passive house building was built in Darmstadt in Germany. So it has a long and successful track record, and the implementation of the passive house standard is still overseen by the International Passive House Institute in Darmstadt in Germany, with local chapters in most countries around the world, including Australia and New Zealand. And it's widely used. There are around 80,000 certified passive house buildings around the world, which makes it the most widely used sustainable design and construction system in the world. This is a map of passive house certified buildings. It doesn't show all 80,000 buildings. It shows about 4,500 certified passive house projects that have elected to be listed in the International Directory of Passive House Projects and share the details of their work for all to see. You can see that it's predominantly a European phenomenon. It started in Germany and spread throughout Europe. It's big in the UK, and it's gaining a lot of traction in the US and Canada. So there are a lot of passive house certified buildings in colder, heating dominated climates like Germany, Sweden, Japan, Korea, Boston, Seattle, and New York. But the point I want to make here is that it's also being applied in hot climates. You can see there are passive house buildings in California, in the US on the left. There's a collection of them there. In Mexico, there's also passive house buildings in Southern Europe, in Portugal and in the tip of southern Spain, and in Sicily and Malta, which are warm climates. In Athens, in Greece, there's passive house buildings. In the United Arab Emirates, in Dubai, in Guangzhou, in China, and in really hot and humid climates like southern China, there are passive houses which demonstrate that passive houses can work in warm climates as well as cold climates. And you can see there's a collection of passive house buildings in Australia and New Zealand also. Now, this is a photo of the first high-rise office building to be built to the passive house standard. It's a 27,000 square meter, 21-story modern commercial office building. It's located in Austria, it's Vienna in Austria, and it was built by the Raiffeisen Holding Company as its headquarters building. It's known as the RHW2, RHW standing for the Raiffeisen Holding Company of Niederösterreich in Vienna, in Wien, so W for Vienna in German. RHW2 because it's the second office building built by the Raiffeisen Holding Company. The one next door was their former headquarters building, and this is their new headquarters building. So this one was built in 2012, and it's tenanted by the Raiffeisen Holding Company themselves as the single commercial tenant, owner-occupier. It's a modern commercial office building that wouldn't be out of place as a premium commercial building in Melbourne or Sydney as the headquarters of one of the big four banks. If you're familiar with 700 Bourke Street in Melbourne, which also has a large central atrium as the headquarters of the National Australia Bank, or the headquarters of the Commonwealth Bank in Sydney, in Darling Quarter, one of the sort of greener buildings in the commercial Arena in Australia, also has a large open central atrium. So this building format, it's built to passive house, but it still fits the building format that you'd expect for a large commercial banking tenant. You can see it's got a beautiful central daylit atrium, but it's also got a kindergarten and a catering kitchen, 250 car parking spaces. It's what we think of here as a normal high-performance commercial office building, except it's also a passive house. And you can see a picture of the kindergarten there and a picture of the central breakout area where people can eat, and the dining precinct. It cost around 84 million euros to build, and it has 6 basement floors. So as I said, a really normal commercial office typology that wouldn't look out of place in the skylines of one of the Australian capital cities. It's got a double skin facade, but it's also got great views. It's on a bend in the Danube River adjacent to the historic centre of Vienna, and those great views aren't compromised because it's a passive house. It does, while it does have a spandrel panel, which you can see in the top right image, it doesn't compromise the views. You can see that it's got great views over the historic precinct of central Vienna. And I think it's a cool looking modern commercial office tower that I think is really in keeping with modern architectural vernacular. So I think this passive house building has really achieved that balance between a modern contemporary design and world's best practice, energy efficiency and indoor environmental quality. The next example I wanted to talk to is a student accommodation tower called The House, built by Cornell University on Roosevelt Island in New York. And you can see the image in the center at the bottom. It's immediately adjacent to New York, to Manhattan Island. And this is currently the tallest passive house commercial building in the world. It's a student accommodation building that was completed just last year in 2017. It's 26 stories high, and it has 352 units, which will all be dedicated to student accommodation, and it will house about 530 students for the Cornell teaching semester. It's got a modular facade system, so you can see the image that I've just flashed up. It's got a prefabricated wall system that was built in a factory, so that when it's installed, it achieves the air tightness criteria, but it also reduced the construction time on site and resulted in a really efficient build process. The next example I wanted to talk about is a master plan community called Barnstadt, located in Heidelberg in Germany. It's a 112 hectare passive house district for about 12,000 people in Heidelberg, but it's also a science and biotechnology innovation hub. So it has office buildings, research laboratories, university teaching facilities, as well as thousands of residential buildings, residential dwellings in these sort of 6-story typology type buildings. And they're all certified to passive house. You can see in the bottom right, a really interesting facade image showing one of the research laboratories, also certified to passive house. The next examples I want to show are a collection of residential, well, this one's a residential building. This one's called Bolueta. It's in Bilbao in Spain. It's a 28-story tower, 88 meters high. It's a residential tower with 108 units. But what I find really interesting is 63 of those 108 units are social housing rental units. So it'll be completed, I think it was due to be completed toward the end of 2017, so it should be completed now. And it's in a climate that's much like Melbourne. It gets to more than 30 degrees in summer in Bilbao and down to about 3 degrees in winter. So they do have a significant cooling demand in Bilbao. And so it demonstrates that, you know, high-rise residential passive house built for social housing units is perfectly feasible in a climate like Spain. So passive house is great for social housing because it's low energy and there are low running costs for occupants while maintaining that high comfort. So vulnerable people who might not have a lot of money to spend on energy bills because they're in social housing will still have great indoor environmental quality and high comfort conditions, but they'll benefit from a low energy bill. So I think passive house is really well suited to large-scale social housing and student accommodation type buildings like the Cornell example. This one is twin residential towers to be built in Vancouver, Canada. This is downtown Vancouver, which is a really high-rise, high-density precinct. This is 1,400 Alberni Street, so 1,400 Alberni Street in Vancouver. And it received planning approval in 2017 with a completion date in 2022. So it's at the west end of downtown, a really high income area of Vancouver. This is a New York Art Deco style, which I think is really well suited to passive house. You don't want too much glazing in a passive house because you want to control those solar gains. And so the Art Deco style that they've adopted, I think, is really a great design that maintains those appropriate window to wall ratios. It's not overglazed. The developer is Lander Global Property Group out of China. The two residential towers are 43 and 48 stories in height, and it will house 450 units, 129 of which will be rental apartments. So about 1/4 of the building's units will be offered in the build to rent market. So this is a great example of the asset class build to rent, which is very popular in the US and Canada. In fact, in the US, the build to rent market is the largest asset class for institutional investors. So large pension funds, large companies that want to invest in real estate, they can build residential buildings and they own the building, they retain it, they service it and they manage it, and then they offer those units for rent rather than for sale. And that's the build to rent model. And it's something that's receiving a lot of attention here in Australia, because we have a need to build more housing. We've got a housing affordability crisis, so we need more units, more houses, more high density. And the build to rent market is a way institutional investors can foot the capital cost of building those buildings and offer them for rent in the Australian market. So the other thing about this 1,400 Alberni Street development by Lander Global Properties Group is that it's consistent with the City of Vancouver's target of all buildings being zero emissions by 2030. So this is a great example, a building to be built in 2022, not that far away from 2030, that will have very low CO2 emissions because it's high efficiency passive house buildings that with a small amount of renewable energy procurement through the grid will be able to achieve zero carbon and therefore be consistent with the City of Vancouver's planning objectives. And we're seeing this more and more around the world, that cities are setting targets like zero carbon by 2030 or 2040. The City of Sydney has a target to be zero carbon by 2030, and AMP Capital has a target for all its commercial office properties to be zero carbon by 2030. So we're seeing these targets more and more. So pretty much new buildings that are built between now and 2030 should be aiming for these very high standards of energy efficiency, and passive house is a fantastic way to achieve that outcome. The next example is a residential building in Changxing in China. And the interesting thing I find about Changxing is it's a really hot, humid climate. It's quite similar to Brisbane. It reaches over 30 degrees in summer and it never gets below 15 degrees in winter. So it's a really warm climate with a lot of humidity. So this is a great example of a building that's been built to passive house standards specifically for a warm, humid climate, which is one of the more challenging environments to build for. This building's known as Bruck, B-R-U-K, which in German means bridge. It's a 5-story building with 2,200 meters squared of floor area. There are 46 residential units. It was built in 2014 by the Landseed Development Group, and it won the gold medal for World Green Building Design. This building's been studied during operation since its construction in 2014 through to now over the last 3 years by the German Passive House Institute. And it's been shown operationally, not just in hypothetical modeling, but in actual energy consumption, to have a 95% energy saving relative to similar residential buildings in Changxing in China, built to the normal building code. So a huge energy efficiency improvement in a warm, humid climate. The other really notable feature about this building is the external facade system, which you may be able to discern there some sort of terracotta and yellowy colored rods on the facade. These are fixed window shades made out of terracotta rods that shade the facade. And then the fixed external shading has both horizontal and vertical components to prevent solar gains through the glazing. So really good example. I think it makes the facade pop and gives a bit of architectural interest to the facade, but at the same time, it's performing a really important function of preventing the solar gains. And you can see that they've used some of those pop-out shading elements as balconies, and some are just windows. The next example is a passive house nursing home in Innsbruck in Austria. This was built in 2013. It's 7,046 meters squared with 118 passive house certified nursing accommodation units for the elderly. And passive house, again, is a really great typology for aged care, where you've got people who are vulnerable, they're on fixed income, so they don't want to be exposed to price shocks around energy, and that they want those very stable, low energy costs, and they want those very comfortable, stable temperatures where they're not going to suffer from being overheated or too cold. The next example is a hospital in Frankfurt in Germany, which is due to be completed in 2019. So this is a modern hospital building with 10 operating theaters. It'll have 666 beds over 6 stories. It will be 78,000 square meters, so a really big floor plate, and it will accommodate about 2,000 employees and serve about 80,000 patients each year. It cost 240 million euros to build, and it's, I think, a great example of a commercial hospital operation that's being built to the passive house standards. The local authority currently incurs annual energy costs of around 3,350 euros per hospital bed at the existing hospital, which this will replace, and that's expected to drop by 80%. So they might be substantially lower, perhaps 600 euros per bed per annum. So much lower operating costs for the hospital, which means that they can invest more in patient care. So passive house is one of the ways that the local authority in Hesse, another one of the states in Germany, it aims to become zero carbon by 2030. And this police headquarters building in Hesse in Germany has been built to the passive house standard. It had about a 20 million euro construction cost. It's a 4,000 square meter building. It's a government administration building built by a progressive public body, leading the way for passive house office accommodation by making its police headquarters administration building a passive house. So I think this is a great way for local authorities that have and increasingly have zero carbon aspirations in line with science-based targets and the best available evidence from climate science. We need to get to zero carbon for new build by 2030. States like Hesse are adopting that, and some great examples of commercial buildings here demonstrating that a pathway to low carbon, high performance, highly comfortable, resilient buildings is possible using the passive house standard for commercial buildings. So I just want to wrap up now, summarizing. Passive house is a performance-based design and construction method developed by German building physicists in the 1990s, and it's constantly been refined since that date. This is the best you can get. This is the best of German engineering in the building environment. It delivers great outcomes, high comfort, high quality, efficiency, and resilience to climate change, all things that, for instance, investors in commercial property are increasingly looking for. While it may cost more, estimates are that in commercial buildings, the premium for passive house is somewhere between 3 and 9% more. So not a significant capital uplift given the 90% lower operating costs, particularly for institutional owners who are going to maintain ownership of a building, or for instance, in the RxW2 context, they're going to continue to own and operate that building as the owner, so they can see the advantage over the long term of the higher capital cost due to their lower operating costs. There's also been a Green Star crosswalk document produced by the Australian Passive House Association in partnership with the Green Building Council of Australia, and you can get 30 Green Star points for certifying to passive house. So this is something that's increasingly being looked at by commercial building owners, is how do I get a Green Star rating with a least cost outcome? Well, passive house might be a great way to get a really strong Green Star commercial building. There are 11 certified projects in Australia to date, with a strong pipeline of about 71 registered coming through, being built at the moment. So there's lots happening in Australia in the passive house space. And as a sustainability professional, I've been working in sustainability since 1999. And I feel that passive house is truly inspiring. These are the buildings that, for me, they are fit for the future. They're comfortable, they're low energy, they inspire me, and I hope they inspire you too. And that's the end of this presentation. Thank you for your attention.